Hello YouTube, I'm your host Philipp Meyer, and today I'm gonna tell you something about oscilloscopes and laser shows. Okay, how that do this go together? I will show you. Okay, the story starts with this Tektronix 603A monitor I got from eBay. It's not really an oscilloscope, but it's a vector monitor. It's an oscilloscope without these fancy oscilloscopes functions in it. It has X, Y, and Z inputs. Let's take a look around these, please. It's quite a deep device. I will explain you why it's so deep. Here you see the inputs, 3 inputs, X, Y, Z, and yeah, that's basically it. The deepness of the tube. The tube actually runs from here to the very end of the device. This is because these tubes are not magnetic, have no magnetic deflection, but they have an electrostatic deflection. And the deflection plates, they have to be much longer than a magnetic deflection coil. That is why these tubes are that deep. On the Vectrex, you might remember, they have a magnetic deflection coil, and that is why the Vectrex fits in normal TV case, basically. Yeah. So I got this thing off eBay, and I can switch it on. And yeah, what we get there is it has a storage tube, and what you see here is the stored image from the last time when I've used it. You can erase the screen, you can set the intensity. No, I don't want the intensity to set too high, because it might burn the phosphor, and then I can use this as a magnadoodle actually. And maybe this is how Magnadoodle was born. You might remember this toy in the early 90s. I had one too. It's a fake edition, but it was basically the same. It had 2 knobs, and you could rotate a pin, and the pin scratch it in a surface, and then you put it upside down, shake it, and then the image was erased. Okay, we have to shake the electrons here and to erase the image. It's quite a nice device. I really love it. It's a very beautiful piece of technology. Okay, let's see the intensity a bit darker so that it's set properly. That has a certain reason for later use. Let's put the point in the middle. Okay, erase the screen. For the next things I want to show you, we don't need the storage functionality. That's why I switched off at the first place. So anyway, I got this, and since I'm a hobby laserist, I have all these laser gear lying around. You see my easylase-usb here. It's an output controller for the projector, and what I've made is the ilda signals. They are differential, analog differential signals, and I convert them to single-ended at some pots, and then I fed them into the vector monitor, and I can see the ilda image on the vector monitor, and I can check the image quality or whatever I want. Okay, let's take a look at the schematic. It's really easy. Here we have the ilda bus tab. I have an ilda input and an ilda output. I always built it that way, because doing it this way, it doesn't violate the bus concept of ilda. ilda has basically a bus concept, even if it's not mentioned in the documentation, but you see it when you look at the interlock, how the interlock works, and you have to propagate it. But that's another topic. Here's interlock is just straight through. You can add a laser projector at the output, and interlock circuit is still alive. There's no problem to operate them at the same time. Here we have a power supply, because the op amps, they need plus minus 12 volts. I do it with a DC-DC converter, and the DC-DC converter also provides full insulation. So we have no ground loops running around here. It's better, I think. It's a bit more expensive doing so, but anyway, I like it. More expensive and then it's more quality. I don't want to sell it as a consumer device anyway, so the price is not the major design decision here. This is one of these converter stages. It's differential. It's an op-amp TL071 in differential circuitry. Very simple. Can find it in every electronics school book. On the output stage, on the output of the amplifier, I have added an 10K potentiometer to have the ability to adjust the signals a bit. I know this is not that clean design, because if you have the pot here, it's sometimes it might ruin the impedance, the output impedance, because the output impedance is changing with when you turn the potentiometer. Anyway, it's not really a problem here, since the input impedance of my vector monitor is very high and the cables are short, so it's not a problem. But yeah, you could add a voltage follower if you want to, but it's not needed. Yeah, the schematic is on the internet. I've written the URL in the comment section, and if you want to build one by yourself, you can do it. It took me a day to assemble all the parts into this nice box here. It's really easy. It's exactly that what you expect from a cold winter day. Okay, the easylase is shipped with test utility and with API and Linux drivers as well. They aren't open source, but yeah, for the normal laserist use it's okay, but maybe if you want to hack something, you might run into trouble. So one day I will have my own laser output card anyway, but yeah, not yet. So we do it with the easylase. We can write single frames with this utility and set the DMX channels as well, which okay, I will write an image to the easylase now. Okay, where is it? No errors. Okay, good. Yeah, get status, it's ready. Good to know. Okay, easylase write frame. I think it's right. So this one contains the easylase logo, and now it's displaying the easylase logo. Can adjust the brightness a bit, and what you see here basically, you see the image presented as dots. I will explain later why is it the case. To explain it, I insert another frame. It's called the ilda test image. This is the ilda test image. This is when you want to verify the speed of your laser projector. You display this test image at a certain angle. It has to be 8 degrees, and doing so you can display this image, and you have to calibrate your galvanometers accordingly. That the I think it was the circle must be inside the quad here, I think, but I'm not sure at the moment. Before I tell you shit, just ignore this. But what you can see is, what is quite interesting is, if you look at the dots, they are tied together, and here the distance between two dots. Here the distance very little, very tight, and here it's the distance is higher. This is I think this is basically because laser projectors are very similar to CNC machines, computer numerical control. You know that in a computer numerical control system you have interpolating software device, I don't know, running in a microcontroller, and it's outputting outputs nominal values for the position controller, or maybe it's called servo controller. I don't know, in Germany we say Lageregler. So but the clock of this nominal value output is constant. In a NC machine it's about 20 milliseconds. I don't know the time base here, but the output of the points should be constant as well here. And this also this means that the axis here is increasing the speed. Here the speed is at a constant level, and here it's slowing down again. More points means that the axis is moving slower. That is why it's normally it's a mechanical scanning device, and you know F equals mass multiple acceleration. Okay, it's accelerated. It's negative acceleration when it's slowing down, and multiplied with the mass, you get a force, and the scanner has to handle this force. I also have some lasershow software running here. In this case, it's the LDS, Laser Design Studio from Retrix. I got this copy from eBay for I think €100, as well as the dongle. It's a dongle software. You can't use it without the dongle. It's pretty annoying, but yeah. Anyway, I tried to get familiar with this software, but I wasn't successful yet. It's very complicated, difficult to use software. It's, I don't know, it's just creepy. But they ship their software with a nice demo, lasershow, which presents all the nice effects you can perform with Laser Design Studio. And this I will show you now on the oscilloscope screen. Okay, let's play it. I think we are through now. Anybody still looking? I don't think so. Okay, the device is quite warm. Let's play a bit with the storage mode. I don't know. Okay, let's switch it off. Goodbye.